So back when we were learning functions, we studied something called the vertical line test. And the vertical line test exists to test whether or not a graph represents a function. Okay, so if you recall what the vertical line test tells us is that if you have a graph and there's at least one place that you can draw a vertical line and it intersects your graph in more than one spot, then the graph does not represent a function. Okay, because really what that vertical line is doing, it's locating an input, an x value that has more than one output. Okay, so now we're going to talk about something called the horizontal line test. Okay, so now that you're being introduced to this, make sure you keep the two straight. A vertical line test is for testing for a function. The horizontal line test is trying to test whether or not your function is one-to-one. Okay, so if you read at the top there, it says that the horizontal line test says a function is one-to-one if no horizontal line intersects its graph more than once. Okay, so basically what this is saying, okay, we will be performing this horizontal line test on something that is a function, so it should pass the vertical line test. But you're trying to test whether that function is one-to-one. Okay, so if there's at least one place where you can draw a horizontal line and it intersects your graph in more than one spot, then the function is not one-to-one. Okay, let's give it a shot. Okay, in example 2, I have 4 different pictures. Okay, all 4 graphs are functions. We are trying to figure out whether each function is one-to-one. Okay, so here we go. Example 2. Okay, the graph of a function f is given. Use the horizontal line test to determine whether f is one-to-one. All right, so let's take a look at the graph in part A. Okay, it's a parabola. Clearly, if you look at this, if you draw a vertical line here and there, no matter where you draw a vertical line, it will only intersect your curve in one spot. So this is clearly a function. Okay, so now we're just trying to figure out if this is a one-to-one function. Okay, so we need to draw horizontal lines. Okay, so this one's pretty straightforward. Okay, pretty much anywhere I draw a horizontal line, it's going to intersect my graph in more than one place. Okay, so what this tells us is that this is not a one-to-one function. Okay, why is that? Okay, well, let me show you. Okay, let me draw a slightly different horizontal line. Okay, so something like maybe right here. Okay, this horizontal line also intersects the parabola twice. Okay, what's happening here when your horizontal line intersects the curve? It's catching two different inputs that share the same output. Okay, so if you look right here, okay, this point on the parabola, I was trying to draw it so it represents the ordered pair -2, 2. If x is -2, the y value is +2. And this point is 2, 2. So if x is 2, y is also 2. So basically, these two spots are showing you two different inputs that share the same output. Okay, so I'm going to say here, you can clearly see that the inputs x equals -2 and x equals +2 share the same y value. Which is y equals 2. Okay, so that's why this horizontal line test works. If you can draw a horizontal line somewhere that's going to intersect your curve in more than one spot, that horizontal line is just basically locating two inputs that share the same y value. Okay, and that means that the function is not one-to-one. Okay, all right, let's look at the graph in part B. Okay, it's similar to -x cubed. Let's just start drawing horizontal lines. Okay, so I'm going to draw one here. I'll draw another one here. Draw another one here. Okay. No matter where I draw my horizontal line, okay, it's just going to intersect my curve in one spot. Okay. So that's telling me that every y value has a unique x value. Okay. So this one is a one-to-one function. Okay. There's no sharing going on. Okay. If we jump to the top of page 2, we have a couple more graphs. Okay. Notice in part C what's going on with this curve. This right side is climbing very quickly. This left side is getting closer and closer to the x-axis, but not touching or crossing it. So this is going to be the x-axis is a horizontal asymptote. So let me write that down. The x-axis is a horizontal asymptote here. So keep that in mind. All right, so let's practice drawing our horizontal lines. Okay, so I'll draw one here, another one here. Okay, pretty much anywhere I draw my horizontal line, it's just going to hit the curve in one place. Okay, that one didn't work out so well. Even if you're down here close to the x-axis, okay, remember the graph is getting closer and closer to the x-axis, and it's never going to touch it or cross it. It's getting infinitesimally closer and closer to the x-axis. Okay, so your horizontal line that you draw, even down there, it's only going to intersect your curve in one spot. Okay, so this is a one-to-one function. All right, part D, the graph is a horizontal line itself. Okay, so you may be wondering, well, what does this mean? Okay, it's a lot more difficult to draw horizontal lines here. So let's just think about points that are on this line. Okay, so this point right here, it has coordinates 1, -1. Here it's 2, -1. This is -1, -1. This is -3, -1. I'm just kind of eyeballing a few points on the line and writing down their coordinates. And you can see here that these 4 spots that I've called out, they all have different x values, but they all have the same y value. So they're sharing, actually every point on this line shares the same y coordinate of -1. Okay, so since there's sharing involved, okay, this is not a one-to-one function. Okay, and I'll go ahead and put, because every point on the line has a y value of -1. Okay, so there's sharing going on. All right. If you wanted to think of this particular graph in terms of the horizontal line test, okay, there is a way you can draw a horizontal line so that it hits your curve in more than one spot. Okay, and the way to do that is to draw the horizontal line on top of itself. Okay, it's going to the horizontal line through the horizontal line itself, it's going to intersect it at every single point. Okay. All right, so now that we're understanding kind of what the concept of one-to-one means, okay, we're ready to talk about what an inverse function is.